Nucleus. When the scientists studied different elements, they noticed that they were made up of the tiny particles called as atoms. Atoms consist of many particles represented by nucleus. Nucleus is the axis around which nuclear chemistry revolves. So nucleus is too small. It carries most of atom mass inside, and its mass is much greater than the mass of electrons. Electrons are negatively charged, and they turn around nucleus at a greater speed. Amount of positive charge in atom is equal to amount of negative charge. Therefore, it is electrically neutral. The reason of positive charge of atom is due to particles called protons. These are positively charged and show with P+. In atom, there are also neutral particles. These are called neutron and shown with N degree. Number of nucleon in the atom is equal to some proton and neutron. This is named as mass number and shown with A. Number of proton in the atom is called as atomic number and shown with Z. This is also equal to number of electron in the natural atom. This number determines the position of the element in the periodic table. This number can be shown with the following order around symbol of the element. Radioactivity. Radioactivity is the property of some neutral element that have unstable nuclei which disintegrate to nth various ray, alpha, beta, or gamma. The unit of radioactivity is the Curie, which equal to 3.7 multiplied 10 to power 10 disintegration per second. The SI unit of radioactivity is the becquerel, which defined as 1 disintegration per second. Radioactive element decays at fixed commonly indicated by the half-life, which is the time needed for the half of the radioactive nuclei to decay. Type of radiation: alpha particles, beta particles, gamma rays. First, alpha particles. These are positive charge particles, as an alpha particle is made of 2 protons and 2 neutrons. It represents a helium nucleus. It is shown with 4 mass and 2 atomic number of helium. It has largest mass amount radiation types. Its properties: alpha particles have a great effect on matter because the particles cause electrons to be free when they hit substance, cause them to be ionized. Number 2. Effect of these particles on matter is very short as alpha particle compared with 2 electrons which have been free. Second, beta particle. They are equivalent to electron with respect to alpha particle. They penetrate more into matter because volume of alpha particle are bigger than volume of electron. Third, gamma rays. Gamma rays are made up of natural electromagnetic waves, and they have a speed close to speed of light. These are the strong rays. They are more effective in penetration of matter, strong, and they can travel further. This figure shown as the effect of magnetic and electric field on the radioactive particles released from radioactive source. Nuclear reaction. Changes which occur in nucleus and cause it change into another nucleus are called as nuclear reaction. For example, release of alpha rays from uranium stops causes formation of thorium stops. Types of nuclear reaction. We can divide the nuclear reaction into 4 parts. 1. Radioactive spontaneous disintegration. 2. Non-spontaneous nuclear reaction. 3. Nuclear fusion. 4. Nuclear fusion. Isotopes are the nuclei of given elements with a different number of neutrons. For example, hydrogen element has 3 isotopes. These are: number 1, normal hydrogen, H. Number 2, heavy hydrogen or deuterium, D or H. Number 3, heaviest hydrogen deuterium, T or H. Medical applications. Use the radiation in medical to provide diagnostic information in wide range of disease by nuclear medicine imaging. For example, number 1, whole body bone scan. Number 2, the thyroid function. Number 3, thyroid cancer. Number 4, pulmonary embolism. Number 5, kidneys. Number 6, to measure blood perfusion in the brain. Effects of ionizing radiation on molecules in living beings. 1. Physical risks. They cause leukemia, bone marrow cancer, thyroid, bone cancers, and malignant tumors. 2. Genetic risks. Ionizing radiation weakens ability of fertilization and cause fertility along with some genetic deformation. Besides, they can cause genetic mutations. Ways of protection from radiation. The factors that determine how much radiation is required are the types of radiation, the type of cell, and the environment of cell. There are 3 simple ways to reduce the staff radiation. Number 1, minimizing the time near the radiation source. Number 2, maximize the distance to the source. Number 3, use shielding where possible.